Hello everybody. This will be class 3. This is our DITA Fundamentals class. As I say at the beginning of each of these sessions, unless I make an egregious mistake, I'm going to just try to correct my mistakes as I make them, if I make them. If I make an egregious mistake, I'll start over and try again. So far we've been in good shape. So this is our DITA Fundamentals class. So one of the first things that I'm going to do, hopefully you did this already with your XML fundamentals, which was class 2. I'm going to, right here on my desktop, I'm going to create a new folder, and I'm going to call it DITA-CLASS. That'll be where I put all of my all of the things that I download and everything that I do for this class. It'll make it easier to find if you put it, I mean, you don't have to do it this way, but I'm recommending that you do. Name it something that's intuitive to you. The next thing I'm going to do is, for today's session, I know that every session I need to download some files. So I go to my D2L, I go under course content, and for this class I know that I need to, this is class 3, so I know that I need to download the slides, so I will download the slides and put them in that directory. I know that for this class I need some files out of the resource directory. So in the resource directory we have a number of files. I would recommend that you download all of these files, and you might even do something like this. You might even, in your DITA class folder, you might make a new folder called Downloads. And you might just want to download all of the things in the resources directory. So last week, hopefully you already downloaded this XML file from the resources directory. If you haven't, I recommend that you do that for sure. This week, for sure, download this DITA download. Okay, so you're going to want to download that and download it to your directory. If you created a downloads directory, definitely download that there. Okay, and then also this is very important because you're going to need this for the rest of the class. Remember, I mentioned to you that I created an open toolkit that has all of the all of the bugs that I've discovered fixed. So rather than downloading the files from the open toolkit on the DITA.org, I recommend that you download this PSU-DITA-OT-2.2.0. Please download that and put that in your downloads directory. Okay, so I'm going to do that. I'm going to simulate that because I actually have this. I'm going to go ahead and download that. So that's downloaded. You will have downloaded it. It will go in your PSU directory. Now, I recommend that you put this right on your root directory for your class. So even though you downloaded it here, you can do a copy and then take it right to the root of your DITA class and paste it there. Of course, with Mac, it's a slightly different procedure. I'm going to assume that you know how to do copy and paste and moving files around and so forth. If you don't, please contact me and I'll be very happy to help you with that. So I'm going to extract this here, and I'm going to let it extract right to that same directory level. So I will extract. Okay, so it's extracting that those files. And then, of course, I've also got my DITA files that I've downloaded. So I'm going to grab those two from my download directory. Okay, while this is downloading, I will pause the tape. Okay, so we've unzipped the Open Toolkit, so we have that. And also in our downloads directory, we have this DITA file that we downloaded from D2L. So I'm going to extract that as well. Actually, I'm going to copy paste this. Copy. I'm going to go to my root directory, my DITA class. I'm going to paste it here. And I'm going to extract it here. And I'm just going to let it go ahead and extract there. Okay, now once I have these, I can go ahead, since I already have these files in my downloads directory, I'm just going to delete the zip files just to kind of keep it clutter-free. So now I have my Open Toolkit and I have my DITA files for today's lesson, today's class. So now I'm going to move this to the side. I'm going to move my resources directory, my D2L, and I'm going to go ahead and start the slide presentation. I'm going to, as I say in most of the classes here, I'm not going to be in presentation mode. I'm going to just show the slides because I'm going to be periodically giving demonstrations throughout this class. Okay, so in this session, one of the disclaimers that I always make, these slides cover the concepts covered in the third session of the DITA Fundamentals class, but some of these slides are repeats from class 1, but they're appropriate for this session. This is, even though it says this is an in-class session, because of a scheduling conflict I had, regrettably, I'll have to do this as an online session. So this week, we will not have the quiz on XML. We're going to move that to next week. But we will have the DITA Fundamentals. So we're going to talk about DITA Topics, DITA Maps, images, command line interface, installing the Open Toolkit, and we're going to look at the DITA content management system that we'll be using in class called easyDITA. So today, hopefully you've read the DITA Part 1, Part 2, Section A, Part 3, Section D, and Section E, and Part 6, Sections K and L. And then for next week, please read the easyDITA tutorial. Okay, so for today, let's start looking at DITA. DITA is the Darwin Information Typing Architecture. Darwin Information Typing Architecture. It's an OASIS standard. It's at the URL that's in this slide. DITA is an open standard that defines an XML architecture for designing, authoring, managing, publishing content. DITA is a topic-based system. DITA is a mature standard, broadly deployed and supported. DITA 1.2 is currently supported by the tools and will be the version we will focus on in this class. DITA 1.3 is the latest version. It was passed December 17th, 2015. We will learn some of what's new in DITA 1.3, but it's not yet supported widely by the tools, so we will stay with DITA 1.2 for this class. While there are many DITA success stories, there are some failures, and we're going to go over those in class so that you don't step into those holes yourself. The number of DITA topics and maps per output, their nesting and hierarchy usually cause complexity, making a content management system necessary. DITA operations require many roles: information architect, writer, editor, system administrator, publishing specialist, translation coordinator, and many more. We'll go over all of these roles in class. So this is DITA. This is a web page. It's a data sheet on the web, and it's rendered, but its source is DITA. The source of that DITA is a content management system. This is not the content management system that we will be using in class, but this is a commercial content management system. This slide is just meant to demonstrate that for this particular data sheet, there are 200 topics and maps. and the complexity is pretty staggering. You wouldn't want to manage this on a file system, so obviously a content management system is the way to go. So this is the DITA, the code view. In this class, I like to make sure, as I use the analogy, learning how to drive with a manual transmission before getting your automatic automobile. I'd like to make sure that everybody understands the code, is comfortable with the code, and that will make using the graphical user interface a lot easier. So this is a map. You can see that it's got that it's XML, first of all, and that it's got links to other maps and other topics. This is a topic. This particular topic happens to be a reference, so you can see the XML and you can see the actual content that gets rendered down the road. So DITA and topic-based. Topic-based versus document-centric. Before DITA and topic-based authoring, the prevailing standard had been document-centric. And there was a very good standard also in OASIS called DocBook. DocBook is widely used and widely supported by the tools. In DocBook, all of the topics that make up a document are one big single file. So that's to distinguish document-centric publishing, which we will not be covering in this class, versus topic-based authoring, which is what DITA is. So DocBook is an example of document-centric authoring. So back to the DITA topic-based authoring. This let's just take a look at what a typical DITA project breaks down to be. So this is a PDF file of a data sheet. It's page 1 of 26 pages. If we were to do it in DocBook, we would see that it would be, you could do it, but it would be one giant XML file with each of these paragraphs and topics in the single file. With topic-based, with the maturity of DITA and topic-based authoring, the mainstream is moving toward topic-based, so that's a good thing. And we'll show you the distinction in a minute here. So DITA is an open standard. It's widely used and supported by tools. In DITA, all topics that make up a document are in separate standalone files. These topics can be reused across many documents. So here's an example. Here's the same data sheet, but let's look at it as a DITA sample. You could actually find this data sheet on the web at that URL there. It's page 1 of 26 in a PDF file. In this the file that, or the project that makes up this document, there are 200 topics and maps. 60 topics and maps are reused in other publications. This is a real-life example. So at my work, we know that this data sheet is made up of 200 topics and that 60 of those are used in the user manual and other manuals or other data sheets. So that's kind of how reuse works. So if you think about it, we've got this. This is just kind of an illustration to prove or to demonstrate this concept. We have on the left-hand side here the DITA map. The map contains links to other maps or to specific topics. In this case, if we think about that data sheet that we just saw, this map then is what pulls all of the topics together. It links to the introduction.DITA topic. It links to the key performance specs.DITA topic and a bunch of other topics. So the way reuse works is if we have this data sheet master map that we were just talking about, and I've greatly simplified it here, but just to show what I mean by reuse, this data sheet is linked to key analysis features topic, key protocol features topic, everything in blue here, the introduction topic, and the key performance specification topics. Obviously there are many, many more, but let's just say that this map points to those. The user manual map also points to the key analysis feature topic. So this topic is used by 2 different publications. It points to the general safety topic, which is not in the data sheet, but is linked into the instrument online help. and so on and so forth. What you can see here is that the topics are used by different outputs, different maps in different publications, and potentially in different languages. So the complexity can get quite staggering. So if we were to look at this particular example in DocBook, if this is a single DocBook XML file and all of the files are in the file, it would not be easy to share this key performance specification topic because it's locked into a single file. That's the beauty of DITA and topic-based authoring. Okay, so what are the parts of DITA 1.2? Well, the ones that we will focus on mostly in this class are topics and maps. There's other stuff in DITA 1.2, but that's beyond the scope of what we'll be talking about in this class, though the graduate students will cover the glossary topic. Okay, so, but the basic primary parts are in topics you have concepts, references, and tasks, and you have two kinds of maps. You have the DITA map and you have the book map. Okay, so let's get started with DITA topics. Topics are, the DITA topic is the basic unit of DITA content. A topic's scope is a single subject. So we're not going to have a topic that has triggering and maintenance. We're going to have one topic for triggering. We're going to have one topic for maintenance. A topic is short enough to be specific to a single subject or to answer a single question. It's long enough to make sense on its own, to be authored as a standalone unit. Okay, those are kind of the boundaries of a topic. We're going to talk about four kinds of topics. There's the generic untyped topic. The topic is just called topic, so it's a topic. It's sometimes called the cheater topic. Using it is not a best practice, and we'll go into why that's why we say that in a little bit later. So the generic topic basically looks like this. It has a topic start tag and end tag. It has a, as we learned in the XML section before this, it has a doc type declaration that points to the topic DTD. And then it has some content. It has a title. It has a short description. It has a body, and it has a paragraph. Okay, the next kind of topic is a specific topic. It's the concept topic. The concept topic answers the question, what is? Or it answers what is questions. The concept topic should stand alone or provide an overview or background information for tasks or reference topics. But keep in mind, the context topic is meant to provide for the task or reference. The context of the content. Let me try one more time. As I said, unless I make an egregious error, I'm just going to keep soldiering through. The context, the concept topic is meant to provide for the task or the reference, cannot be guaranteed to accompany that task or reference in all maps. Okay, so that just means that it's a standalone topic. All concept topics must be written to stand on their own. So this is what a concept topic looks like. Again, it's got all the XML stuff that we are accustomed to seeing. It's got the doc type declaration and so forth. Its root element is concept. It has a title. It has a short description. It has a con body, and it has stuff in the con body. In this case, we're just showing a paragraph. Obviously, these examples are very, very simple. They can get more complex than what I'm showing you. Okay, the reference topic. The reference topic is called the Just the Facts Ma'am topic. That's a line from an old TV show, Dragnet. One of the characters would say, "Just the facts, ma'am." The reference topic should stand alone or show examples of a concept or list the values associated with a task. Keep in mind, the examples or values the reference topic is meant to provide for the task or the concept cannot be guaranteed to accompany that task or concept in all maps. Therefore, all reference topics must be written to stand on their own. This is the XML version. Like I said before, it's got the XML stuff, the doc type declaration. It's got its root element is reference. It has a title, short description, a ref body, and then different kinds of elements that are specialized to the reference topic. The task topic answers the question, how do I? How do I do this? How do I do that? These are task topics. The task topic is empowered to thoroughly document a procedure, but contextual and references information should be contained separately in the concept and reference topics. Keep in mind, procedural tasks topic is meant to the procedural task is not guaranteed to accompany the task or the reference or the concept topics. In other words, all topics must be written to stand on their own. Okay, so this is kind of what a task topic looks like. Again, it's got all the XML stuff. Its root element is task. It has the basic elements that you would expect, and it has some unique elements that are unique only to tasks. Okay, so those are the topics. Having hundreds or thousands or millions of topics floating around doesn't do you much good if you don't have a way to corral them, to gather them, to present them, to organize them in order to make a publication. In order to do that, we use maps. Maps are the mechanisms in DITA that enable topics to be organized for creating outputs or archives. Maps enable order and hierarchy of a set of topics. Maps come in two formats, the DITA map or the book map. The DITA map is the one we'll start off with first. The DITA map enables links to topics. The DITA map enables links to other maps. The DITA map provides holders for metadata. The DITA map allows relationship tables that create dynamic information sets and enable linking outside the content of individual topics. Note, for this class, we will not be expected to know the mechanics of relationship tables, only that they exist and their purpose. Okay, so this is the XML version of a DITA map. You see that it has all of the XML stuff, the doc type declaration. Its root element is map, and it has a title. And then the power of maps is this topic ref. The topic ref then points to either other topics or other topics, or even in some cases other maps. A book map is a specialization of the DITA map that provides specific mechanisms for adding book-centric markup to enable turnkey book publication. The book map provides syntax for adding front matter and back matter, parts, chapters, and appendices, and book metadata. So here's the XML code view of the book map. It has all of the XML stuff. Its root element is book map. It has a book title. It has chapters, and then within the chapters it can have topic references to other maps or to topics. Okay, so we've covered what the topics are. We've covered how you link them together and get them in the order that you want for a publication or for archiving. Now let's talk about images in DITA. Images can be added using the image element to point to an image file using the href attribute. If you are adding a caption to an image, it is advised that you put the image element inside a fig element and use the title to add the caption. So here's a concept topic with an image. So we see here that we have, as we said before, a fig element. Within the fig element we have a title, and we have an image element, which is an empty element. Or no, it's not an empty element because it has an alt that is within the image element. And we have an href that points to a directory and then the actual image file. In this case, it's a JPEG with a rather large name. Okay. Okay, so that's fundamentally how DITA topics, maps, and images work. You'll become more and more comfortable with this as class goes on. In order to process these things, though, we need tools. One of the fundamental tools in most open source and commercial tools for authoring DITA or for content management systems or any other DITA related tool is, at the heart of it, 99% of the time, is the DITA Open Toolkit. The DITA Open Toolkit does command line processing, and we're going to look at exactly how that works, and then I'm going to demonstrate that for you. So the DITA Open Toolkit transforms DITA XML source content into deliverable formats like PDF, HTML, and help systems. Nearly every DITA tool has a version of the DITA Open Toolkit integrated within its framework. The DITA Open Toolkit is open source, and you can see the URL there. The DITA Open Toolkit is the standalone DITA Open Toolkit runs at the command line. Now, as I said before, it's not likely that you will get a DITA job where your job will be to run the DITA Open Toolkit at the command line, but knowing how the command line works will be very important to you. Okay, and I think I said that in the last bullet. If you work in a DITA operation long enough, you or somebody on the team will need to get involved in the DITA Open Toolkit at some point. It might as well be you. And here's one of my editorial comments. Your pay, the degree to which you are perceived as vital to the operation, will go up. How do I know that? Because I am a hiring manager who has hired people in a DITA organization. Okay. So here's how it works. You download and extract the DITA Open Toolkit. If you were out in the wild, you would go to DITA.org, DITA-OT.org. But as I told you before, I recommend that you download the version that I debugged and put on D2L. So you would download it and then you would extract it. And I showed you how to extract it at the beginning of this video. So here's what we're going to do for this class, and I want you to follow along. And I'm going to show you how to do this after I go through these slides. So after I go through these slides and then after I demonstrate it, I want you to please do this yourself in the DITA class directory that you created, okay? But I'm just going to walk through the steps now. So first you need to create your own DITA project in the Open Toolkit. So you navigate to the DITA Open Toolkit and create a new folder called PSU. Then you need to create a DITA project in the PSU folder. So there are a couple of ways you could do that. If you're good at DITA, you can just make one yourself. Or if you're a beginner, you could copy all of the slides that I just went through and paste them into files. You could copy this, copy, paste, make sure you get the close element into a, and then save it as something called concept2-w-image.dita. Similarly, you could do that with the book map and the DITA map and the task topic, the reference topic, the concept topic, naming them what I have in these parentheses, or even the generic topic. So that's one way you could do it. Excuse me while I page down through these slides. I hope I don't give anybody whiplash. Or there's another way. My hint 2 is that you could just paste in the sample DITA project you downloaded from the resources on your D2L site for this class. So when you do that, you download the DITA from the resource files directory, as I demonstrated earlier. You would unzip it. You would copy everything that's in that directory, and you would paste it into your PSU directory. I'm going to show you exactly how to do that in just one moment. From there, of course, you need to start the DITA Open Toolkit. So in Windows, it's easy. You just double-click the command prompt in Windows. In Mac, you have to go to your utilities. You have to go into Applications and then Utilities, and then double-click on the Terminal app. You need to invoke the DITA Open Toolkit command line. So in Windows, you just double-click the start command.bat file. On the Mac, you have to navigate to your DITA Open Toolkit, and you have to type the command sh space startcmd.sh. When you do that, you will see this ominous warning that the DITA Open Toolkit people have put in there that says, note, the DITA start command has been deprecated. Use the DITA command instead. Don't worry about that. That's not going to cause any harm. Just ignore that. Once you get in there, you should type Java space -version, and hopefully you'll get something affirmative. Similarly, then type ant space -version, and you'll get something affirmative. Don't worry if you get this little error when you do the ant, that it's unable to locate the tools.jar file. That's a benign warning that's not going to hurt anything. So in DITA Open Toolkit 2.0 and later, you use the DITA command in most cases, and here are the arguments and the options that you can use and the syntax. The outputs, there's a number of outputs that come right out of the box, and we'll look at some of those in a minute here. So then for this class, I would ask you to compile the sample that comes, or that we just created, and make sure that you get a PDF at the other end. So to do that, you would type DITA space -I for input, and you would type the name of your PSU directory, and it wants the DITA map, the master DITA map, and then space -F for format. In this case, you would say PDF, and then -space for output. In this case, you would type PSU out, and that's going to be the directory it will create. Then you will press run or enter. So let's see if I can remember all of those steps and actually give you a demonstration of that. So first of all, we have to go to our DITA class folder, and within it, remember, we downloaded the PSU DITA Open Toolkit 2.2.0. So let's go into that, and then let's make a new folder, and as we said, we'll call it PSU. Okay, so you'll do that. Please do that yourself. You can either pause and do that as I'm doing these steps, or you can wait until after and you can try to do them all yourself. Okay, so we have our PSU directory. We're going to go back to our DITA class directory, and we're going to go into that DITA directory that we downloaded, and within it we have this DITA sample. So let's go into that, and let's select all. So I'm going to select all of this, including the images directory. Okay, and then I'm going to hit Control C, which will copy it. So I'm going to hit Control C. On the Mac, it's Command C, or you could even do Edit Copy. But you need to get these things on your clipboard. Then you go back to your DITA class, back to your PSU, back to your your Open Toolkit, and then your PSU directory. Okay, hopefully everybody's following along, right? I'm in my Open Toolkit. I'm in my PSU directory. I'm going to hit Control V, which is paste. So I've just pasted all of those files from my downloaded DITA from resources into my downloaded Open Toolkit in the PSU directory. So remember, I said that that's the way you could do it in my, I believe I called it hint 2. So then the next thing I need to do is, if I'm in Windows, I simply double click the start command.bat. If I'm in Mac, I need to get my terminal. I need to change directories into my desktop and change directories to my DITA class folder, and then change directories into my PSU Open Toolkit 2.2.0. So I'm going to simulate that. Even though I'm on Windows now, I know that those were a lot of steps, so I'm going to go ahead and simulate that by going into, I'm going to pull up a command prompt. Okay, so this is going to be different than on the Mac, but basically what you'll do when you're on the Mac is you'll do CD space DESKTOP, enter, and then you'll do a CD space DITA -CLASS, enter, and then you'll do a CD space PSU DITA OT 2.2.0, enter, and this will put you at in your directory you need to be in. And then if you're on the Mac, you would do an SH space START.CMD, and you would press your return key. I'm not going to do that because I'm not in Mac for this demonstration, and I wouldn't get the desired results. But that would instantiate your Open Toolkit and set all your environment variables the way you need them to be set. I'm just going to bail out of this because it's not going to do me any good. Since I'm in Windows, if you're in Windows, as I said, all you do is you double-click your start command.bat, and you'll see the note that comes with the Open Toolkit. The start command bat has been deprecated. Use the DITA bat command instead. And then I added a series of notes after I modified that command. This version of the DITA Open Toolkit 2.2 has been modified by me for the PSU DITA class. Please do continue to use the standard the start command file for the PSU class. So I press any key, and what that does is it brings up my my command line that has all of the variables set and everything the way I want it to be. So remember, then the next thing I said was that I will type ANT space -F space, and I'm going to pull these slides back just because I can't remember exactly what I said I needed to enter. Okay, put that down here. Okay, so I'm typing, whoops, I started to do the wrong thing. Ah, that's right. Okay, so instead of doing that, I will type DITA space -I space caps PSU in capital letters /MAP1.DITA-MAP space -F space PDF space -O space PSUOUT. Now I'm assuming I didn't do any typos there. I'm going to press my enter key, and it's going to think for a while. And again, I said that it might give you this unable to locate tools.jar. That's completely benign. Don't worry about that. It's thinking about, it's doing some processing in the background. This is in silent mode, so it doesn't tell you all of the things that it's doing. This is a bit of a difference from when you use the ANT command, which we will use later, where it just shows you everything that's going on and all of the processing that it's doing. So while this is thinking, what we are hoping for, the good sign that tells us that we have success is right there. The command prompt comes back and no errors were displayed in the terminal. So that's a good sign. So remember, we said that we were going to, the output was going to go in something called PSU out, and sure enough, it created PSU out, and within it is a PDF file. If we look at the PDF file, it sure enough created a PDF file, and it has all of the rendered topics. Remember, if you looked at the code view, we saw the code view, but this is kind of nice because you know, a title looks like a title, a paragraph looks like a paragraph, the images look like images, and the table looks like a table, etc. So that's good news. That's success. So even though I didn't say how to do this in the slides, I'm going to go ahead and do another one. I'm going to I'm going to make some HTML. So I'm going to type DITA space -I space, and then my input is still my DITA map, so I'm going to type PSU/map1.DITA map. But now for my format -F, I'm going to say HTML5 and space -O, and I'm going to put it in, I'll call it PSU HTML, enter. And again, it gives me that unable to locate the tools.jar file. Again, that's completely benign. What we hope for, what we're waiting for, is the command prompt to come back with no errors. And assuming we did everything right, we get that. It did come back. So now let's go back into our Open Toolkit. And sure enough, PSY HTML. I guess I must have mistyped that. Yeah, I did. PSY. Okay, well, it did what I told it to do. And in it, it gives me these HTML. So if I go to the index file, it creates the image file. Actually, I'm going to do an open with. I'll just say Chrome. And sure enough, it gave me the file, and they're all linked to nice HTML5. Okay, so this is how we do the command line, the Open Toolkit. It's all very straightforward. You just have to make sure that you don't mistype things, and if you do, just try again, and you'll get the Open Toolkit to work the way you want it to work. So that was a pretty quick demonstration. I would like for you to, if you haven't done it already, pause the tape and do exactly what I just did. At least make the PDF file. You can refer back to the slides. You can refer back to me doing it on the video. But it's important that you're able to do this yourself. If you have any trouble, please contact me, and I will be happy to walk you through. Okay, so I'm going to put this away and put this away and go back to our slides. So again, please make sure that you're able to do this, and please let me know if you need any help. Okay, so we did this. We talked a little bit about using the ANT command. Before DITA 2.x came out, with the 1.8.5, you had no choice but to use the ANT. These are the steps on how to do that. We're not going to use this method for creating output. We will use this method for creating when we get into our translation section and our XLIF sessions. So I'll show you how to do that. But in case you want to use the DITA Open Toolkit 1.8.5 to create output, these are the steps for doing that. You can go ahead and try it if you'd like. But I would recommend that you use the DITA command. Now, having said that, you could even create your own ANT built files in order to do the processing. This is something that can be done with DITA Open Toolkit 2.2. So I'm going to demonstrate this. You will not be expected to know how to do this. It won't be you won't have to do this in your project, but there might be a question about it on the quiz or in a test. So I'm going to go ahead and demonstrate this. You can read how to do this on page 335 of the Introduction to DITA book. But basically what you do is you create your own XML file. This is a very simple version, but it will certainly work. You can get much more extravagant than this, but let's just take a look at this. This is a build file, and then once you've created this build file, again, instructions for how to do that are in the Introduction to DITA book on the page that I cited earlier. You would save the XML, and then you would type ant space -f space and then the file name that you just saved. So let's go ahead and do that. So I'm going to copy this file, And I'm going to try to not get that last, carriage return. I guess I'll do it this way. I'm copying it. I'm selecting the text, and I'm doing Control-C to copy it. And then I'm going to bring up my text editor of choice, the one that I like best. When I'm in Windows, the one I like best is Notepad++. And if you just pardon me for a second, I've got a bunch of files open in it, and I want to close these. Okay. Okay, almost ready. Okay, almost ready. I'm in the off-screen clicking close to all these files, so I have a blank editor here. Okay, Notepad++, I'm going to say File, New, and I'm going to do Control-V for paste, and then I'm going to save. What did I say that I want to save it as? psu.xml. Control-C. Okay, so I'm back in Notepad, or Notepad++. I'm going to save, and I'm going to save it to my desktop. And I said that I have a directory called DITA class, and I'm going to save it to the PSU Open Toolkit, and I'm going to call it PSU_PDF.xml, and I will save that. Okay, so that's on the desktop now, and let's verify that. Oops, wrong one. Okay, so we'll go to that directory, and sure enough, there it is, psu.pdf.xml. Okay, so I'm going to bring up my command prompt again. So I'm going to do start command. And that brings up my enabled command line. So I'm going to type ANT space -F space PSU_PDF.xml, and I'm going to hit enter. Now this is a very verbose version. ANT is different than DITA. It shows you all of its dirty little secrets. So it shows you all kinds of code, and it just spins and spins and spins. So you might see some warnings here. Just ignore those. When you're using ANT, the big thing you want to look for is a big print on the screen that says build successful. And if you see that, then, and you don't see, have it complain with an error, then you're in good shape. So this says build successful. It said that it took 26 seconds. So let's see, in that build file, where did I tell it to go? I said, oh, my output directory is PSU out. So it's you're going to have to take my word for it that it made something new here. PSU out, and it made this map with the current timestamp. So it indeed made what we wanted it to make. So that's how you use the ANT. That's how you build your own build file with ANT and how you execute it. Okay? So CMS. A content management system automates the output creation. So in this case, we have an HTML output and a PDF output. Content management system means a different thing to different people. Some people think of web content management systems. Some people think of enterprise content management systems. For this class, we are concerned with component content management systems, CCMS. So why do we need a content management system? DITA operation is complex with many moving parts. We have reuse, single sourcing, shared topics and maps, images, between outputs. We have multiple versions of each topic, map, or image. We have multiple language of all of these topics, maps, and images. We have an overwhelming number of files. So in this case, we have a data sheet that references several topics. We have a manual that references some of the same topics and some of the different topics, and we have a whole bunch of images. So if we were to manage that on the file system, that would be difficult. So here's the example that we looked at earlier. We have a data sheet that's printed that's 26 pages, a typical data sheet. If we were to cut that up and say, what are the different topics, we have 205 of them in this example. So if we calculate the typical document file density, if we have 26 pages, that's 205 topics, 23 maps, and 24 images. It takes 252 files to make up a 26-page data sheet. That's about 10 files per page. If we think to ourselves on a standard website, we have one data sheet and one manual for each product. And if we say we have 100 products on our website, that means the average data sheet is 25 pages, the average manual is 150 pages, the average density is 10 files per page. If we have 100 products, one data sheet, one manual each, and we have an average number of languages is 6 languages, that means we have over 1 million files on that website just to make up one data sheet and one manual for each product. That's very complex. So would you like to try to manage that on a file system? Theoretically you could, but a better way to do it is to use a component content management system. So a content management system is an application that enables creating, editing, versioning, translating, and publishing content and output, usually through an intuitive graphical user interface, which we call GUIs. The content management system manages workflow in a collaborative environment. The component content management system is a content management system focusing content primarily at the granular level and secondarily at the document level. Each component represents a topic, map, or image. The component content management system manages versions of topics, maps, and images, and it manages the relationship between topics, maps, images, languages, and publications. The one that we will be using in class is easyDITA. I will be handing out credentials shortly, and you will be able to log in and you will see the easyDITA interface. easyDITA, there's no software to install. I will provide each student with a login and password. It's a complete DITA solution. It includes what you see is what you get, and a code view for authoring, repository, and publication. It's on the cloud and it's web-based. Okay, so here's an easyDITA example. What you will do, you will create a project. You will be given a set of parameters and requirements to mimic this data sheet. I've created one in easyDITA that I will give you complete access to, and then you'll see exactly how to do it. Okay, so that's today's class. Hopefully I didn't fumble through too much of it, and hopefully it was clear to you. I hope that you were able to follow along and create the DITA Open Toolkit project as instructed in the slides. If you have any trouble, please let me know. And that will conclude today's presentation. Thank you. Goodbye.